Greetings, parasite ecologists. When we're talking about arthropod vectors, the mosquitoes absolutely deserve their own video. Even though they are tiny and easily swatted, they are considered to be the most dangerous animals on Earth. Why? Because the parasites they vector, especially the malaria parasites, kill hundreds of thousands of people every year. Remember, mosquitoes are in the class Insecta and the order Diptera. They're just a single family of flies, plain and simple. And yet this one family is responsible for a huge burden of human pain and suffering. The mosquitoes are hands down the most important insect vectors of human disease, more so even than the lice or the fleas. They are also the most common blood-sucking arthropods. There are over 3,000 described species and probably many more that are undescribed. They're also vectors of diseases like malaria, lymphatic filariasis, various kinds of encephalitis, and so many more. So there are many reasons to fear mosquito bites. Let's talk briefly about the mosquito life cycle. Mosquitoes go through 4 stages of development. Adult female mosquitoes lay their eggs on the surface of fresh water like ponds, lakes, puddles, but also in human-made freshwater sources like bird baths, plastic pails left outside in the rain, old tires, and untended swimming pools. The eggs float alone or in groups that look like rafts. Eggs laid during winter can survive to hatch in the spring. Out of each tiny egg hatches a larva. The larvae live at the surface of the water and breathe through a tube. As the larvae grow, they shed their skin a few times in a process called ecdysis, or molting. If mosquito larvae need to hide from predators, they can swim and dive below the water's surface. Mosquito larvae live a few days to a few weeks before they turn into pupae. They stop feeding just before this transition. The pupae live at the water's surface and breathe through small tubes. Mosquito pupae do not eat, but they are active. They tumble below the surface of the water when they're disturbed. They remain in the pupal stage anywhere from 1 to a few days, depending on the water temperature. When it's ready, the adult breaks out of the pupal case and crawls onto the surface of the water. It rests there while its exoskeleton hardens and its wings dry. The mosquito is now a flying land insect. Adult mosquitoes mate, and the life cycle continues. Now I want to drill down and talk about one species of mosquito in particular, Culex kincaefasciatus. It's a fascinating mosquito. It's synanthropic, meaning it likes to live near human habitations because it is really good at breeding in cesspools and latrines, which is disgusting but true and part of why they do so well in the presence of humans. This is one of the main vectors of lymphatic filariasis, and it exists across a broad swath of the world. These guys can breed in sewers and other gross, wet locations that are really hard to treat. Controlling mosquitoes in general is hard to do, whether they're like Culex kincaefasciatus breeding in sewers or in easier-to-treat areas. For an example that's close to home for some of us, I want to take you back to the 2008 financial crisis. You probably remember, or at least you've heard, if you're a little bit on the younger side, that 2008 was a terrible year for the U.S. and the global economy. And here in the U.S., many people got underwater on their mortgages, and the bank foreclosed on their homes. Across the country, in the wake of the financial crisis, people got kicked out of their houses. And when houses are foreclosed on, no one's living in them anymore, and no one is tending to the swimming pool. The bank owns the house at this point, and the bank doesn't hire a pool cleaner. These pools can become breeding grounds for mosquitoes, resulting in elevated instances of infectious disease transmission. At just about the same time, West Nile virus was spreading across the U.S. It wasn't a good time to let the mosquito populations run wild. A few years after the financial crisis, I was working with Santa Clara County Vector Control in Silicon Valley in California. Santa Clara County had a massive problem with untended swimming pools. Their interest was in figuring out ways to quickly and easily go to all of these untended swimming pools and ensure that they weren't breeding mosquitoes that could have transmitted West Nile. And they decided on a biocontrol option that allowed them to throw a couple of things into the swimming pool and leave, knowing it would be protected against mosquitoes. They used mosquito fish, or Gambusia affinis. This species is invasive worldwide, and it's been spread to many countries from its original range for this exact purpose. It is used as biocontrol for mosquito larvae. These mosquito fish are very good at eating mosquito larvae. You can see that they have this upward pointed mouth that's exactly designed to pick mosquito larvae off the surface of the water. And they can live in dirty, warm, standing water. So Santa Clara County decided to dump mosquito fish into all of these abandoned swimming pools, which was an effective way to reduce mosquito production from these untended swimming pools. This is an example of biological control, or biocontrol, which is the use of natural enemies to control pest populations. Natural enemies include predators, competitors, or parasites that reduce the abundance of a pest. Often, biocontrol is used to control invasive species, or the vectors of infectious disease. Many pest species, including some mosquitoes, are non-native. In these cases, the natural enemies of those pest species can be found in their native range. For native pests, like many of the neglected tropical diseases that we've talked about, biocontrol has to be more creative because we're already in the native range. All the native predators, competitors, and parasites are there, and yet the parasite is still a problem. When thinking about biological control, we often consider parasitoids and parasitic castrators because parasitoids kill their host and parasitic castrators castrate the host, reducing fitness to zero. We aim to reduce the fitness of the host to zero, and so parasitoids and parasitic castrators can do that. That's why they're often selected. So in classic biological control, we locate natural enemies where the pest was native and introduce that natural enemy to control the introduced pest. The goal is to reconstruct the ecosystem and all the controls that would be on that species in its native range. A good biocontrol agent should have a density-dependent response, killing more pests when the pest is abundant. It should be host-specific, so it doesn't kill things we don't want it to kill. And it should be an efficient searcher within and between pest populations, keeping the pest population size low and finding pests even when they become uncommon. The uncommon pests are the most important to get because they could reseed the entire population if control is relaxed. We want to find that last mosquito to ensure that we reduce the population to zero completely. A good way to think about this is to consider Australia's rabbit problem. A departure from the arthropods, but just humor me a moment because it's an interesting example. There are a lot of rabbits in Australia, but they're not meant to be there. They were introduced when Australia was a penal colony as a food source for the convicts who were dropped off there. And since then, their population has increased into the millions. In 1950, some folks introduced the virus myxoma into Australia to control this rabbit population. It did kill quite a few rabbits, resulting in many dead rabbits as the virus spread through the population. This was done using classical biocontrol methods. European rabbits were controlled with a European virus. It worked for a while, but there were just a few rabbits that, through random chance, had resistance to the virus. All the rabbits in Australia today are descendants of those resistant animals and are totally resistant to myxoma. The rabbit problem is just as bad as it ever was. But biocontrol isn't always a failure. There can be times when it can be a success. A really good example is the elimination of schistosomiasis in some areas of the Caribbean. Remember, schisto was introduced from sub-Saharan Africa into South America as a result of the trade in enslaved people across the Atlantic. It was able to establish because Schistosoma mansonis intermediate host Biamphilaria species snails were already present in the region. Researchers introduced Melanoides tuberculata, a competitor of Biamphilaria in its native range, and this resulted in the successful eradication of schistosomiasis from several islands in the Caribbean region. Schistosomiasis doesn't exist on these islands due to competition from Melanoides tuberculata, driving Biamphilaria either to local extinction or to very low levels of density. So biocontrol is often attempted to reduce the abundance of arthropod vectors and other pests. It doesn't always go as intended, but it can work if carefully thought out. We attempt to control mosquitoes in so many ways. Biological control, yes, but also chemicals, using bed nets, personal insect repellents, draining wetlands where mosquitoes breed, helping people eliminate breeding habitat from their properties like tires and bird baths, and lots of other methods. And yet, there are still many mosquitoes in the world. A mosquito is just really, really good at its job, and its job is to survive and to bite. I'll see you in the next video.